polynomial functions. Our objective here, we want to identify polynomial functions. Okay, what do we know? Well, we know what a polynomial is. A polynomial is a mathematical expression of one or more algebraic terms, each of which consists of a constant multiplied by one or more variables raised to a whole number power. The prefix poly means many. The suffix or maybe the root here, nomial, means in this case terms. And we're going to stick with one variable. We're not going to have multiple variables, okay? But we're going to have a multiple number of algebraic terms. So here's an example of a second degree polynomial, also called a quadratic, ax squared plus bx plus c. Whole number powers. You could write an x here if you wanted to and put a 0, because anything to the 0 power is 1. But it's key to have whole number powers. Okay, so what's a polynomial function? A polynomial function is a function of the form f of x equals all of this stuff, which basically says coefficient times x to a degree that's a whole number, plus the coefficient times x to the next degree smaller, plus et cetera, plus coefficient times x squared, plus coefficient times x to the first, plus constant term or coefficient times x to the 0. Okay? Every exponent is a whole number. N, the largest exponent or the highest power, is the function's degree. So go back up to here. This is a 2, put a 1 there. So the highest power is the function's degree. This is a second degree polynomial. The coefficients are all real numbers. A sub n, which is the coefficient of the variable to the highest power, is the leading coefficient. And finally, when the exponents decrease from left to right, as you see here, decreasing in this case by 1, the polynomial is in standard form. All right, let's take a look at what are polynomial functions and what are not polynomial functions. Okay, in this column we have polynomial functions. Let's take a look at our exponents. I have a 5 and a 2. Those are both whole numbers. Every exponent is a whole number. My coefficients are real numbers, so this is a polynomial function. Letter G, our function g of x down here, I'm going to multiply it out, but I've already done this, so you can practice if you'd like to. I know that x minus 2 times x plus 3 is x squared plus x minus 6. And when I multiply these two, I get negative 3x to the 6th minus 3x to the 5th plus 18x to the 4th. Okay, notice I have whole number coefficient, I have whole number exponents and I have real number coefficients. My exponents are in order, so this is in standard form, and it is a 6th degree polynomial. Okay, the largest exponent is the function's degree. The leading exponent in this case is negative 3. Not polynomial functions in this column. Let's see why. I'm going to write this x, which is the square root of x, as an exponent. Negative 3 times x. The square root of x is the same as the exponent 1/2 plus the square root of 2 times x squared plus 5. And you'll notice this is not a whole number. Therefore, this function is not a polynomial function. I'll do capital G of x down here. Again, I'm going to rewrite this x squared term in the numerator, and I come up with negative 3 times x to the negative 2 plus the square root of 2 times x squared plus 5. And again, we'll notice that this exponent is not a whole number. Therefore, capital G of x is also not a polynomial function. A couple notes. We're going to be working with polynomial functions generally of degree 2 and higher, but just so you know, a constant function, f of x equals c as long as c is not 0, is a polynomial function of degree 0. A linear function, f of x equals mx plus b, where the slope is not 0, is a polynomial function of degree 1. A quadratic function, which we've talked about in the past, f of x equals ax squared plus bx plus c, standard form. We can't have a be 0 because we need the squared term, is also a polynomial function and its degree is 2. Again, we'll be focused here down. We're not going to deal with linear. We're going to deal with degree 2, degree 3, degree 4, and higher. So there you have it, how to identify polynomial functions.